Good morning, class. So welcome to Physics Laboratory online class. Okay, so today we will be showing you how to perform experiment number 1, which is kinematics. Okay, so when we say kinematics, so this is the study of motion without including the causes of the movement of the object. And the motion of the object can be classified into different kinds, like it can be classified as linear motion, it can be also the in terms of projectile motion, and then rotational motion or simple harmonic motion. But today we will be only doing the first type of motion, which is linear motion, and the projectile motion. Okay, actually the first part is more on vertical motion, and then the second part is projectile motion. So free-fall motion is simply the motion of the object because of the effect of gravity, in which we are only considering the vertical motion or the y-axis. And in free-fall motion, so we are also considering the effect of gravity, which is constant. So we need to compute for the acceleration due to gravity, which is 9.8 meters per second squared. So the objective of this experiment is to verify if the acceleration due to gravity is really 9.8 meters per second squared. Okay. So in this experiment, we'll be using this equipment. So we'll be using the picket pens. Okay. So this one is the picket pens. Okay, so this one is the picket pen. So this is the object that we're going to undergo the free-fall motion. Okay, and then we have the photogate head. So the photogate head is used to sense or to measure the acceleration, the distance, the position of the picket pens. And also we have the photogate mounting rod. Okay, of course this is used to connect to set the photogate in place. We also have so this is the GLX Explorer. Okay, so the GLX Explorer is simply like a computer in which it stores or it measures the different quantity that we need to measure in physics. Okay, I will show you how to use the GLX, siguro maybe later. Okay, and then so this is the digital adapter. So the digital adapter is used to connect the sensor, okay, to the GLX. And of course we have the cable. So this is the cable which is attached to the photogate head. Of course we will be using different kind of clamps. We have the metal rod, we have the A-base support or the A-base, which is used to set up everything. And then we will be also using the soft pad. So this is used to, of course, for us to prevent the damage in any case in our photogate head or picket pens. Okay, so to start with this, again, the objective is to verify the value of acceleration due to gravity. Again, the value should be 9.8 meters per second squared. So in our experiment, so we will be measuring the distance of the first block to the last block. Okay, so this will be measured by the photogate head. And then at the same time, the photogate head will measure the distance from this to the last block. Okay, so whatever be the velocity, whatever be the distance, whatever be the time, so that will be used in computing for the acceleration due to gravity. So the acceleration due to gravity is, or can be computed by the formula v squared per 2y. So the v squared, so that's the square of the velocity or the square of the speed, and then the denominator, which is y, so that's the distance, the vertical distance. Okay, so to start, so we'll be setting the GLX. Okay, so we need to, actually if you want to turn this on, you need just to press this button, long press. But in case this is drained, you just need to connect the charger, and then automatic the GLX will open or will turn on. And then it will automatically be set to the set sensor. Okay, but in this case, so we have different options. Okay, so in our experiment, we'll be using the photogate head and also the picket pens. So we need to select the picket pens and photogate head. So here, photogate and picket pens. So just press the check button, and then press the home button, and then home button. So that will be the you will see the different the menu, okay, or the different setup that we'll be needing in the experiment. So in this experiment, we'll be setting this to digits. Okay, and then the first quantity is position, So we'll be needing another quantity, which is velocity. Okay, just press the check button, down, check button again, and then there will be option velocity and acceleration. So let's set that to velocity. Okay, now we have the quantities, position, and velocity. So since the formula for acceleration due to gravity is v squared over 2y, so that's simply square of the velocity here divided by twice of the position. So I'll press the play button to start the reading, and then in dropping the picket fence, yes, okay, you just need to make that the picket fence should be perpendicular to the water gate head. Okay, it should be perpendicular or 90 degrees, and then it should be aligned on this side. Okay, so what I will do is I will just drop this one, and then after that, the water gate head will read the distance and also the velocity of the picket fence, and that can be recorded. So that will be recorded in GLX. Okay, first trial. So we'll be doing 5 trials. First trial. Okay, that's it. Okay, so the reading in the GLX is for position we have 3.3. So that will be 0.3 meter, and then for the velocity, so that's 2.45 meter per second. So that will be our first trial. I will be recording that here. So this is 0.3. And the position there is also the vertical displacement, so they are the same. And velocity is 2.45. Okay, and then we will be computing for the acceleration due to gravity later after getting all the data for trial 1 up to trial 5. Okay, so this one is the first trial. Now what I will do is I will stop the GLX and then press the play button again, and then it will be set to 0 again. And then I will be doing the second trial. Okay, again perpendicular, and then release the picket fence. That's it. Okay, so the reading here is for the second trial we have 0.3 and 2.43. So second trial is 0.3, and then the velocity is 2.43. Now let's do the third trial. Okay, one more. Okay, so the reading is 0.3 and 2.46. You press stop and then play button again. So I am now on the fourth trial. Okay, and then we have 0.3 and 2.45. 0.3 and 2.45 as the velocity. Stop the play button and then press the play button again to play to start reading. Okay, so the last reading is 0.3. Velocity is 2.46. Okay, now let's compute for acceleration due to gravity. Okay, again, the formula to compute for acceleration due to gravity is simply v squared over 2y. So v is the position or vertical displacement, and then y is so this is the velocity, and then y here is the vertical displacement. Okay, we just need to use this formula to get the acceleration due to gravity of every trial. Okay, for the first one, so that is simply v squared. So velocity is 2.45 meter per second square over 2 multiplied by the vertical displacement, which is 0.3 meter. So this is 2.45 square over 2 times 0.3 is 0.6. So this one is 10.00. Okay, so this is 10.00 meter per second squared. Okay, so this one is meter per second squared over meter. So the answer or the final unit is meter per second squared. So the first value of acceleration due to gravity is 10.00 meter per second squared. Okay, that's the first value. For the second value, okay, that's simply 2.43. Okay, 2.43 square over twice of the vertical displacement 0.6. So this is 9.84. This is 9.84. For the third trial, 2.46 square over 0.6. So the answer is 10.086 or 10.09. I will be rounding off the answer to 2 decimal places. For the fourth trial, 2.45 square over 0.6. So the answer is 10.004 or simply 10.00. And then for the last trial, 2.46 square over 0.6. So this is 10.086 or 10.09. Okay, and then for us to get the experimental acceleration due to gravity, so that is simply the average of the 5 values. So let's just compute for the average. So that's 10.00 plus 9.84 plus 10.09. Okay, plus 10. Okay, plus 10.09. So that the total is 2501, or the total is 50.02 divided by 5 because we have 5 trials. So the answer is 10.004. So this is 10.004 or 10.00. So the theoretical value is 9.8. Okay, let's compute for the percent error. Okay, the percent error is simply, so this is the formula for the percent error. So this is simply theoretical value. Okay, theoretical value minus experimental value. Okay, all over theoretical value. So this is our formula every time that we'll be computing for the percent error. So that should be multiplied by 100 to get the percent error. Again, theoretical value, or the theoretical value can be the accepted value or the given value, and then this one is the computed value or the value that we will be computing using the experimental data. Okay, and that will be should be always be divided by the theoretical value or the accepted value. So the theoretical value is 9.8. So this one is close to meaning this is absolute value. Okay, so we have 10 or 9.8 minus 10. Okay, divide by 9.8. Okay, then multiplied by 100. Okay, so the answer here is negative 2.04, but our formula has this symbol, meaning the value will be in absolute value. Okay, so the percent error is 2.04. In computing for the percent error or in doing experiment, it's very important that we aim for 10% below error. Okay, so usually if your error is greater than 10, we ask our student to repeat the experiment. Okay, but in our case, our value is 2.04, so meaning we performed the experiment maybe that good, or we're very effective in computing for the data. Okay, so that is for the first part of the experiment. So the second part will be projectile motion. Okay.